are going to use algebra tiles to model polynomials today. So let me first introduce how we're going to do this. Now, so green is for go, red is for stop. So my green is going to represent my positive numbers. That's my little mnemonic device for remembering. And my red's going to represent my negative numbers. So my squares here represent my one unit. Positive 1, negative 1. So what I have here is, this is an x. It is x units tall and 1 unit wide. So this is 1x. This is going to represent negative 1x. Last thing to introduce is notice this square. It's x on this side, it's x long on this side, so therefore this represents x squared. The red square is going to represent negative x squared. So this is how we're going to represent our polynomials. All right, first thing we're going to talk about is adding polynomials together. So let's represent one of our problems here so we can make sure we're clear on this. Oh, not that one actually. Actually, we're going to do this one. Let's represent a polynomial. So I have positive 2x squared. And that represents 2x's minus 3x. When I look at this, this is just negative 3x's. So I'm going to go over here to my negative 3's. And now positive 2. So we can see how we're representing the polynomials. All right, we're going to add that to negative 1x squared minus 1x plus 9. All right, so let's represent that. We have a negative 1x, we have a minus 1x, and I have a positive 9. All right, one of the concepts to remember that's important is combining like terms. Like terms are like, well, you probably heard this before, but you can't add apples and oranges. Well, this is like the same thing. I can't add something unless they're the same things. I can add apples with apples. I can add oranges with oranges. What's nice about that is that my like terms are the same shape. So I can add squares, little squares. I can add the big squares, the x squares, and I can add the x's. So I'm going to put my like terms together. Now, just as when we introduced algebra tiles before, we had 0 pairs, we're also going to have 0 pairs here. So let's see. Well, I don't have any here. I don't have any with the x's, but look, I do have some with the x squareds. So I have a positive and a negative x squared forming a 0 pair. These two are going to cancel each other out. So let's get our final answer. My final answer is 1x squared. 1, 2, 3, 4, but notice that they're red, so they're negative, minus 4x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But it's positive, so we're going to put a plus sign. So when we're adding polynomials using algebra tiles, we're going to represent the problem in the appropriate manner, both of the polynomials, and then we're going to look for 0 pairs. Our goal is to find those 0 pairs so we know what cancels out and then tally up what's left. All right, let's talk about multiplication then. Let's get one of these on there. Actually, we'll just use the one we have. All right, we're going to say this problem times 2. I'll put it over here because it looks nicer. So times 2 means every one of these units is going to be times 2. So this one gets times 2. These 4. I wrote something wrong. This one was supposed to be 4. Sorry about that. All right, so this 4 are going to be doubled. Using the wrong units. Hopefully when you're watching this, you catch that too. All right, and then 9. Well, let's double that too. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have all our things doubled, times 2. If it had been times 3, I would have done 3 of everything. Times 4, 4 of everything. All right, let's see what we got. Nobody was catching my mistakes before, guys. That was supposed to be a positive 1. Oh, I know what happened. It was this one. Sorry about that. 10, 11. Now we're good. Now it all makes sense. All right, now let's tally this up and get our final answer. All right, so my final answer when I times 2 is going to be positive 2x squared 1, 2, 3, 4, 5, 6, 7, 8, minus 8x, and then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. Guys, if I'd been multiplying by a negative number, the concepts aren't going to change. I would still double or triple or whatever I have to do is necessary to each term, but you'd have to remember your multiplication rules from previous assignments. So a positive times a positive is a positive, a negative times a negative is a negative, a positive times a negative is a negative. I think I might have said that wrong. A negative times a negative is a positive. Once you remember those rules, because it's going to change the signs of some of these, you're good. Last concept we're going to discuss is division. All right. All right, so let's model our problem appropriately first. So I have 3x squared. So I'm going to get 3x squared. I'm going to get, now, it says minus 9x. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then plus 6. 1, 2, 3, 4, 5, 6. All right. I'm going to divide this by 3. When I'm dividing by an integer, what I'm doing is forming groups of. Groups of, in this case, 3. So let's do that. So this one's easy. Start off with my 3 groups there. 1, 2, 3. I'm going to start sorting these into groups also. Oh, I counted wrong. Oh, no, here it goes. All right, and then last one. Group. Now, my answer is what is in one of the groups. All right, so let's write our answer. So here's one of my groups. So my answer is 1x squared, it's green so it's positive, minus 3x, negative because these are the red ones represent negative, plus 2. So the concepts are going to be the same no matter what these numbers are. Whatever I'm dividing by is the number of groups I'm going to separate my polynomial into. The only thing to remember is the signs are going to change if I'm dividing by a negative number. All right, guys, I hope that helps. Thank you very much.